Okay, today we're going to work on homework 3, which is a repeated measures t-test. Or a within subjects, within groups design, because we're having the same people in two different conditions. And so, yeah, so we'll just get started. Set up the null and alternative hypothesis. That's pretty straightforward. The null hypothesis is going to be that the mean difference is equal to 0. The alternative hypothesis that the mean difference is not equal to 0. We're going with a bidirectional hypothesis, as we often do. Now, the next thing that we want to find is our standard deviation term, well, it's our standard error term, but we need to find our variance term first, and actually we need to do a lot of other things first. So let's find our mean difference first, actually. And the mean difference is equal to the sum of the difference scores over n. And so our first step is to get our difference scores. And so we put that up over here as a D. And then we're going to need our difference scores squared, but we can get to that in a minute. So 15 minus 17 is minus 2, and then 13, 21 and 21, 0, 3, 6, 0 again, 25 and 25. I'm not keeping quite on the same line. That's okay. Negative 2, 18, there's a big difference. Minus 3, 0, minus 5, 5, 6, 7, 1, 10, 24, 2, negative 4, and then 34 minus 20 is 14. So we get the sum of the difference scores, and we have to include the negative numbers there too. So the minus 2's, minus 3, minus 5. And we get the sum of the difference scores is equal to 93. So we can plug that into our formula. Is equal to 93 over 20. And so our the mean difference is going to be equal to 4.65. Okay. This is, like I said, this is a little tricky because it's asking us for our standard error. So we have to find our variance term first. And the formula for our variance term is the sum of the difference scores squared minus the sum of the difference scores squared divided by n over n minus 1. So we've got the sum of the difference scores, 93. Whoops, there it is, 93. We need some of the difference scores squared. So we'll set up another column of that over here. Difference scores squared. 2 squared is 4. 169, 0, 9, 36, 0, 4. 18 squared is 324. 9, 0, 25, 25 again. 36, 49, 1, 100. 576, 4, 16, and 196, so that the sum of the difference scores squared is going to be 1583. So now it's just a matter of plugging our numbers into our formula. 1583 minus 93 squared divided by 20 over n minus 1, so 20 minus 1. If we break this down, it comes out to be 1150.55 over 19, and that's equal to 60.56. Okay, now we can get our standard error, because the formula for standard error is our variance term over n under a root sign. So it's going to be 60.56 over 20 under a root sign, which is going to be equal to 3.03 under a root sign, which is equal to 1.74. Okay, the last thing that we need to get is our t, which we can put up over here. This is our t obtained, and that's equal to our mean difference over our standard error. And so mean difference is 4.65 over our standard error, which is 1.74. And our answer comes out to be 2.67. Okay, figure out degrees of freedom. Degrees of freedom is going to be equal to n minus 1 because this is within subject's design. So 20 minus 1 is equal to 19. The t critical associated with 19 degrees of freedom is 2.09. And so we compare our t obtained, 2.67, to our t critical, 2.09. And what we find is because our t obtained is greater, that we are able to reject the null hypothesis, that there is no difference between people's ratings of an unattractive offender and an attractive offender. And so we're able to reject that null hypothesis that there's no difference. And that is how to do homework 3, which is a repeated measures t-test.